Good morning, dear students. Welcome back again with the new session of 11th Standard Maths 1 Angle and its Measurement. In this video, we are going to only discuss about the terms used in this lesson with the help of which you can solve all the sums of this lesson. So first of all, we are going to discuss about the terms used in this lesson. The first term is directed angles. Angle traced by terminal ray or arm, which is explained with the help of the diagram. You can see here angle AOB. OA is called as initial ray or arm, which is fixed, and OB, ray OB, is called as terminal ray or arm, which is moving. So here from OA the ray is traced and move up to OB. So here angle is a gap is formed between ray OA and OB, and that gap is represented with the help of the angle, or we call it as theta, that we have already discussed in the previous classes. Now another term used in this lesson is positive angle and the negative angle. Now, from the initial arm, if the terminal arm moves in the anti-clockwise direction, anti-clockwise means against the direction of the clock, that is called as positive angle. You can see in the diagram it is represented that angle AOB, that is OB is moving in the anti-clockwise direction, which is positive, whereas angle AOC, ray OC, is moving in the clockwise direction, which we call it as negative angle. So this is how, or this is what we call it as positive angle and negative angle. For positive angle, terminal arm is moving in the anti-clockwise direction. For negative angle, the terminal arm is moving in the clockwise direction. So that was all about the positive and the negative angle. Now we'll discuss about 0 degree angle. Now to explain the 0 angle, here diagram is drawn. OA and OB, ray OA and ray OB, they coincide one upon the other. एक के ऊपर दूसरा ray. So they are coinciding, and therefore the angle between OA and OB is 0, and therefore the name is given as 0 angle. 0 angle implies here two rays coincide, that is one upon the other. Now the fourth term used in this lesson is straight angle. Now straight angle implies here the angle between initial ray and the terminal ray is 180 degree. Therefore, which implies that opposite rays are formed. Since opposite rays are formed and they appear to be straight, and therefore the name is given as straight angle. You can see in the diagram OA and OB. The angle between OA and AB is 180 degree. It can be either in the on the x-axis or on the y-axis. That was about the straight angle. Now another is angle, we call it as one rotation angle. You can see the diagram, ray OA and ray OB, they coincide with each other, but here ray OA is completing one full rotation and again coming back to its original position. So when they cover one full rotation, that is, it makes 360 degree angle, and therefore the name is given as one rotation angle. So the angle between the two rays 360 degree, it is somewhat similar to 0 angle. Now another type of angle is co-terminal angle. In simple words, co-terminal angle implies the difference between the two angles should be the multiple of 360 degree. That is, the difference between the two angles can be either 360 degree or 720 degree or 1080 degree or 1440 degree, and so on. Here, in order to explain this, here one example is there. For example, 30 degree and 390 degree. The difference between 390 and 30 is 360 degree. Since 360 degree is there, and therefore it is co-terminal angle. Similarly, 420 degree and 60 degree, the difference between 420 and 60 degree is 360 degree. Again, it is co-terminal angle. The other pair of angles are 780 degree and 60 degree. The difference between them is 720 degree, which is the multiple of 360 degree. Again, it is coterminal angle. If the difference between the two angles is not a multiple of 360 degree, then they are called as non-coterminal angle. Now here terminal angle, coterminal angle is explained with the help of one diagram. Here you can see here ray OA is initial ray. Now OB is there, which is 60 degree. It completes one rotation and come back to its original position again on OB, and therefore the angle formed is how much? 60 plus 360, that is 420 degree, and therefore 60 degree and 420 degree is called as coterminal angle. Now standard angle. Initial arm always lie on the positive x-axis, and the terminal arm does not has any fixed position. It can be in the first quadrant or on the first quadrant or on the axis. It can be in the second quadrant, it can be in the third or fourth quadrant or on the axis. So all these positions it can be the terminal arm, and therefore such type of angle is called as standard angle. I repeat again, initial arm has to be on the positive x-axis, and the terminal arm can be any position between 0 degree to 360 degree or even more than that. That is called as standard angle. Now angles in quadrant. Now initial arm is on positive x-axis, and the terminal arm can lie either in the first quadrant or in the second quadrant or third or in the fourth quadrant, anywhere between these 3-4 quadrants, and therefore they are called as angles in quadrant. Now another term is used, quadrant angle. See, there is a difference, angles in quadrant and quadrant angle. The actual difference, quadrant angle implies multiple of 90 degree. Here initial arm lie on the positive x-axis, and the terminal arm can be either on the positive x-axis, positive y-axis, negative x-axis or negative y-axis, which implies that the theta can be only the multiple of 90 degree, and therefore it is called as quadrant angle. That is explained with the help of the diagram. You can see a diagram. One is from x to y, the other is from x to x dash, and the third line is from x to xy dash, and the fourth line is from x to again x, that is 360 degree. In all the four cases, the initial arm is fixed, that is positive x-axis, but the terminal arm is either on y-axis or negative x-axis or negative y-axis, or again return back to the original position. All these positions, 4 positions, are called as quadrant angle. Only 4 positions are there for quadrant angle, but angles in quadrant, there is no fixed position. It can be anywhere between the first to the fourth quadrant. Now angles are measured in 2 forms or 2 units. One unit we are already knowing it, which is already being used in the earlier classes, that is degree. The new form of measuring the angle is radian. So here, if it is measured, angle is measured in degree, it is called as sexagesimal. Whereas if it is measured in radian, it is called as radian. Sorry, if it is measured in circular form, it is called as radian. So here 0 degree equal to 0 radian. Then we'll directly move to 180 degree implies pi radian. So if 180 degree is pi radian, then definitely half of 180 is 90, therefore half of pi will be pi upon 2. So 3 and a half, or sorry, triple multiple of 90, that is 270 degree, can be nothing but 3 times pi upon 2, and 360 degree is nothing but 4 pi upon 2, which gets cancelled and becomes 2 pi radian. I hope you are understanding. Every 90 degree implies pi upon 2. Similarly, for 60 degree it is pi upon 3 radian. For 45 degree is pi upon 4 radian, and for 30 degree it is pi upon 6 radian. Now here see how There is a formula to convert degree to radian and radian to degree. So in order to convert degree to radian, 1 degree equals to pi upon 180 radian. So if it is 5 degree, then you have to convert into radian. You have to multiply 5 degree into pi upon 180 radian, and that becomes pi upon 36 radian. Similarly, if you want to convert radian to degree, the relation is what? 1 radian equals to 180 upon pi degree. So 5 radian will be nothing but 5 radian into 180 upon pi degree. That becomes 900 upon pi degree. Here we have discussed the formula to convert degree to radian and radian to degree. With the help of other numbers, you can try it and convert it degree into radian. Based on this, various sums are there in the first exercise. Now this up to here, all the formulas and terms are based on the for the first exercise. Now for the second exercise, only two formulas are there. The formula is relevant to arc length, and the another formula is relevant to area of the sector. Now what is arc length and the area of sector? You can see the diagram here. S is there, a small part of the circumference, that is AB, arc ABC, arc AB, that is called as arc length, which is represented by letter S. Then radius R is there. An angle between the two ray is represented by angle theta, and the shaded region is nothing but A, which we called as area of sector. It is by seeing the diagram we can say that area of sector is proportional to the angle. Greater the angle, greater will be the area of sector. So here theta upon 2 pi equals to A upon area of circle. Now area of circle formula is pi r square. So theta upon 2 pi equals to A upon pi r square. Now here common term gets cancelled, and thus we get the formula area of sector equals to r square theta upon 2. Similarly, arc length S is proportional to the central angle theta, and therefore the ratio is written as theta upon 2 pi equals to S upon circumference of a circle. Therefore theta upon 2 pi equals to S upon 2 pi r. After cancelling it, cross multiplying it, we get S equals to r theta. Here S implies arc length, r implies radius, and theta is the angle between the two rays. So here we have discussed all the terms and formulas relevant of this lesson, related to both the exercise. Remaining next video will be based on the sums of this lesson. So till then, have a great day.